Okay, hello. Hi Natalie. Good evening. Welcome back to my should I say our November week 4. Okay, this is the last week of November, right? So we are going to continue with our revision today, All right. So we stop at chapter 7, I think. Chapter 6, 7. Uh, I think here. Yeah, we were just talking about this, right? December got class. Yeah, sure. We are still continuing with our revision until you are in your SPM. So we follow schedule, we follow our schedule, if you know our TDC schedule, Same thing, December has 4 weeks, but the last 2 week will be double class because we need to, everyone is going on a break for New Year and Christmas. So if you have the if you have the schedule, if you have the schedule, the calendar with you. Okay, so today let's go to chapter 9. Okay, let's go to chapter 9. I would say this is a very easy to score chapter because for sure coming out and sort of like a bonus chapter. Okay, why do I say so? Because this chapter we learn about alloy. Okay, if you remember what is this? Alloy. And then we learn about glass and ceramic, and of course your polymer. What is a polymer? I will talk about that later. Right. So let's go to alloy first. Okay, let's go to alloy first. Okay, so please put a star here, whatever you want to do here. This is for sure coming out in exam, for sure. Especially the experiment. Okay, especially the experiment. This experiment is I think has come out for I don't know few years of SPM already. A few years of SPM, the experiment question, the 10-mark question, this thing has came out like multiple times, which is a good thing, right? Because if they do it again this year, it will be easy scoring for you. Right, so let's talk about alloy. So what is alloy? Alloy is a mixture of several types of metals. When you take a few metals, you mix it together, you will get alloy. All right, so this process is called alloying. Okay, the process is called alloying. Easy lah, alloy what? So the process you add ing lo. So alloying. So why do this? Okay, why do this? Because as you know, in case you don't know, pure metals, they are very soft. Okay, what do I mean? Pure metals they are you can easily bend them. Okay, if you take a gold bar, if you take a gold bar, you bite them, you bite a gold bar, you can see your bite marks on it. It's that soft, okay? Gold, they are very, very soft, so as other metals. So why do alloying? This is to solve this problem. Number one is to increase hardness, okay, to make them harder. Next is to prevent corrosion so that they don't corrode, they can last longer. Next is to improve appearance, okay? So it's about hardness, corrosion and appearance. So that they are harder, so that they last longer, they don't rust, so that they can look better. All right. They don't oxidize, they will stay shiny for longer. So that's the point of alloy. Right. So we have a few alloys here. We don't memorize all of it. Kindly pay your attention to bronze and brass. Right. Kindly pay your attention to bronze and brass. Okay. Bronze is what we call qing tong. Have you heard of this? Qing tong. The third prize medal is bronze lah. All right. So this thing, what is it made from? Okay, you have to know this. They are made from copper and tin. You don't need to know the percentage, but they are made from copper. Copper is the main material, as you can see. Copper is the main component, and then they add like 12% of tin to make it bronze. All right. So what do we use it for? As you know, like bronze, we use it to make coins. We use it to make medals. Even your monuments. What is a monument? You know Tugu Negara. Tugu Negara, the monument with all the hero who sacrificed for our nation, Tugu Negara, the thing is made from bronze. Okay, Statue of Liberty is made from bronze. All right. So why is it called why is it green now? Because it's oxidized. That's why it's called 青铜 咯, because it's 青色嘛. So they look kind of green now. Okay, so originally, the Statue of Liberty was bronze, like 100 years ago, right? Anyway, so brass, this is 黄铜, as in yellow, you know, your 20 cent, you know, your 50 cent, they're made from brass. So same thing, they are mainly made from copper, but this time we don't add tin, we add zinc. You add a little bit, 25% of zinc, you will get brass. Okay, so bronze and brass, they are very similar. Okay, it's just that brass, they are slightly softer. Okay, they are slightly softer. So we use them to make keys. Okay, we use them to make keys. We use them to make musical instrument. That's why, you know, there's a section of instrument we call brass, right? Okay, if you go to the if you go to an orchestra, you will see woodwind, you will see string, you will see percussion, and then you see brass. Brass are those, you know, golden looking instruments like your trumpet, trombone, French horn, tuba, if there's a saxophone, okay, whatever. So that section there, it's a brass section. So do not drop your brass instrument on the ground because they are actually quite soft. Are they light or heavy? They are actually like they're actually quite light. They're actually quite light. It's just like your keys, like your keys are very light, isn't it? So the trade-off is they are very soft. So you drop them on the ground, they will deform. Okay, so that's the thing. So remember this, copper and tin, copper and zinc, that will be your brass and bronze. The rest of it, I'm not saying that they are not important. It's just that they are very, you know, they are not as common as bronze and brass. Maybe you need to know about steel. What is steel? Steel is your 钢. Okay, 起屋子的钢, the steel you use to build your house. So this is made from iron and a little bit of carbon. Okay, this is to make them hard and strong. Right, and of course duralumin you use it to build planes. Okay, because aluminum is aluminium. That's all. Okay, pretty much that's it. So let's explain. Okay, why is alloy harder than pure metal? This one you need to explain. In exam they will ask you, why is pure metal soft? Why is alloy hard? This is very easy. You just look at the atoms. Can you see in pure metal, right? In pure metal, the atoms are arranged in rows very nicely. Okay, very nicely. So when you apply force to them, they will slide. Okay, so they will slide over each other easily. When they slide easily, this thing will easily deform. So that's why pure metal, when you push them, they will bend. Right? If you take a piece of metal, you just bend them, they will bend. Whereas if you look at alloy, since we add two different size of metals together, so can you see they are not like they are not smooth layers already. They are like, you know, randomly arranged. Now, if you push them, they are harder to slide. So you see, difficult to slide over. Just now, easy to slide over, soft. Now, difficult to slide over, hard. You see, so this is the key word. This is the key point. Easy to slide over, pure metal, soft. Hard to slide over, alloy, hard. End of story. Okay, end of story. So this experiment, I can roughly tell you you should be doing this last year, but last year was MCO so there's no choice. So what is this? You just take a copper block here. Okay, can you see a copper block here? A copper is pure metal. So by right, this block should be very soft. So what do? You put a ball on it, a steel ball. Then you use a weight. You drop it. You whack onto this ball. So what do you see? You will see a dent at the block, right? The block, like there's a dent on it. So by right, copper should have a deeper dent. And if you change it to bronze, bronze should have a shallower dent. What does it mean? That means bronze is harder, alloy is harder. Okay, this experiment has came out like don't know how many times in trial, in maybe the first exam or maybe in your SPM past years. So this is really easy to understand. And due to the lack of experiment in Form 4, this is somehow one of the most common experiment to come out, because there's not much choices they can choose. So this is it. Okay, so pay attention to this. I mean, of course, I will. Have I taught you how to write these things last year? I think I have, right? Last year or this year, I've also forgot already. How do you write aim, problem, variables, and procedure, and things like that? I have, right? So don't worry. I will teach this again, and we will give you a booklet of experiments. You just need to look at all of it, and SPM will come out with one of it. Okay, we will compile all the experiments from your Form 4 and Form 5, and you will see one of it in SPM for sure. Okay, for sure. All right, so what does this prove? This proves that alloy is harder. And then this one, you put iron in water and you put steel in water. So who is going to rust first? This is going to rust first. That means alloy is more resistant to corrosion. Okay, they can tahan corrosion better. So there you go. All right, so this is your alloy. Pay attention to alloy. Again, I said this again. Alloy is very crucial in your exam. Okay, not to mention they are very easy to study. All right, so next, moving on. So your glass and ceramic, good news, don't focus. Don't focus. You can read this for fun. It's not coming up. So glass and ceramic. Glass, they are made from silica. As you can see, this is the main ingredient. Silica is sand. Okay, silica is sand. So you have 4 types of glass here. This is the most common glass. This is purely made from sand. We call it fused glass. And then soda lime is the cheap glass. Borosilicate is the expensive glass. Lead glass is the glass we use in chandelier. We use it for refraction, like prism and your whatever light that you need glass. We use crystal glass. Okay, so ceramic, there's only one type. They use aluminum silicate to make. That's all. This one, just read it for fun. This will come out in objective, so you can just stamp out your way. I don't mind. Okay, I don't care because it's not really coming up. Not worth your time. Right, so next, polymer. Do you still remember what is polymer? Do you still remember what is polymer? When I take many monomer, I combine together, I will get a polymer. Do you still remember what is this? Take for example, if you see glucose here. Oh no, you don't remember. Okay, you know it's glucose, right? Glucose is one simple sugar. If you zoom into glucose, they look like this. Okay, it's like a block of Lego. When you take this glucose, you put them together, 1 glucose, 2, 3, 4, you chantum them into a long chain of glucose. This is called starch. You know starch? Starch is in your rice, your potato. So starch is a long chain of glucose. So you can say that glucose is a monomer. And if you repeat this monomer, you will get a polymer. You get a polymer. So that's all. That's all. Okay, so this process to make polymer is called polymerization. Okay, polymerization. And of course, the reverse is called depolymerization. But the important is this polymerization. And of course, polymer, we have natural polymer like starch, protein, and rubber. And of course, we have synthetic polymer. Synthetic means human-made. These are mainly plastics like polythene. You know polystyrene, the white color thing. When you buy TV or when you buy whatever house appliances, the thing is wrapped in this white color thing to absorb shock, right? That's the polystyrene lah. Polystyrene, whatever lah. So last time when we tapao tapan, this our the fan hub used to be made from polystyrene one, and then Selangor government they banned it lah because it's very hard to recycle. So polystyrene lah, polystyrene, and when you scratch it, you get that very annoying sound. This is your polystyrene, and of course your perspex. This is your also a plastic. We sometimes call it acrylic. Okay, acrylic. Those ever advertisement board plastic, the transparent one. That's your Perspex. And of course, we have rubber. This one just really for fun, not important, because our main focus is our rubber. Right, again, rubber is for sure coming out, almost for sure, because rubber is very important. Okay, first of all, rubber is made from latex. You know what is latex, right? Latex is this white color milky fluid from a rubber tree. That's your latex. And then your latex, when they harden, you will get rubber. Right? I'm sure you can smell this thing. You have smelled this thing before. If you smell glove or tire, have you been to a tire shop before? That very smelly smell, that's the latex smell. Okay, it kind of makes you want to vomit. The rubber smell. Even if you have touched a condom before, a condom smells exactly like latex, really smelly. Okay, so condom is not a very pleasant thing to. I mean, last time when we learned, I don't know your school did this. During when we learn reproduction, the science teachers just asked us to go and buy condom to look at it. Okay, sort of like a sexual education thing. Really smelly. Okay, never had that. Okay, are you ever curious what's on the condom? First of all, it's rubber. Okay, first of all, it's rubber. It's a really elastic rubber. You know how it looks like. Okay, that's good. Do you know it's really slippery? Do you know it's really slippery? Okay, if let's say condom, right? You wear it on a guy's PP. Okay, the outside is really slippery because it's coated with lubricant. Yeah, really stretchable. You can stretch it over your arm and it won't break. That's the thing about rubber. Okay, the good thing about rubber is, you see, it is really elastic. Okay, really elastic, and it's very soft. So it makes very good sound absorber. If you want to dampen sound, okay, let's say you have your aircon, the outside unit is like vibrating, very noisy, isn't it? So the footing, they put rubber because it will absorb the sound, so you feel no vibration. So whenever you want to soften vibration, you will use rubber. So it's like a pillow. They will soften the noise. Okay. So anyway, what is rubber like? Natalie, do you have any idea of? Do you still remember any of this? Just asking. God, okay, go. That's good. That's good. Okay, so you see, your rubber is a polymer. So your rubber polymer, right? Your rubber polymer is like this chain. This chain. So this chain, right? Okay, this is liquid. This is liquid. This is liquid latex. I'm talking about liquid latex, fresh latex. Okay, fresh latex, right? They have this protein membrane around them. And this protein membrane, they are surrounded by these negative charges. Okay, negative charge. So what happens when the other has negative charge? So negative, they will repel, right? Positive repel, what? Negative repel. So negative will repel. So as long as these two polymer, as long as not just two, you have many thousand of this rubber polymer, as long as they don't join together, they won't coagulate. Coagulate. You know what is coagulate? Coagulate means they harden. Okay, I don't say harden rubber or solidify. Please use the word coagulate. Okay, coagulate. Coagulate means they harden. Okay, and before I move on, right, can you please write down something? Acid is positive. Okay, acid is positive, and alkali is negative. Okay, acid is positive, alkali is negative. Okay, why do I want you to write this? Okay, because right. Okay, if you look at this rubber, okay, can you see all these negative charges? Right, what happens when you add acid to it? What happens when you add acid to it? So acid is positive, right? As I said. So this acid will come and neutralize all these negative charge. They will come and neutralize all these negative charge. Now, the plastic membrane, okay, this plastic membrane, sorry, not plastic, protein, sorry, not plastic. Okay, this protein membrane, now they have no more charge, right? So they can't repel already, right? So what happens? Now they will start to crash together. all of them will start to crash together. When they crash together, they will start to clump. When they clump, they will coagulate. When they clump, they will coagulate. So you want this if you are the factory. Okay, let's say you got liquid latex. You want this latex to turn into solid so that you can make tire, you can make condom, you can make gloves. Then this is a good thing. You do this. But if you are the rubber tapper, okay, if you are the rubber tapper, this is a bad thing because factories, they don't want, hard rubber because it's useless already. They have to throw it away, right? So this is what happens. This is why they want to, factories, they don't want this to harden. So, right. So this is why, guys. This is why, do you know rubber tapper? They go for rubber tapping really early. Okay, I don't know whether you know this. Rubber tappers, they go on to tap their rubber at around 3 a.m. By 3 a.m. they have to leave and they will reach the estate at around 4, and then they will tap the rubber until they're like 6 or 7. Then they need to start collecting. Why? They have to do everything before the sunrise. Okay, why do everything before the sunrise? Because when the sun rises, when the sun rises, temperature will get warm, right? Because when there's the sun, it gets warm. When it gets warm, bacteria will start coming inside and bacteria will start producing acid. Bacteria produce acid, right? This is why if you leave your food on the table, like nasi lemak, if you leave nasi lemak on your table and you forgot to put it in the fridge, the thing will 抽酸. You know, 抽酸, sour. When your nasi lemak turns into that sour taste, that's the bacteria lah. Okay, so whether it's warm, when the sun comes out, when it's warm, so bacteria will come in and then they will start producing positive charge, they will start producing acid. And before you know it, the bacteria will coagulate this rubber. Your latex is now useless. All right. Or you can do the same thing by just adding ethanoic acid or formic acid. You will coagulate them as well. So what do you do? How do you prevent this? Very easy. You add alkali. You add alkali. Because alkali is negative, right? Alkali is negative. So they will protect the negative charge on the protein membrane. So now they won't crash together. They will repel. Now this thing will remain in liquid form. Okay, so what alkali do you add? You can add ammonia solution. Okay, things like that. Ammonia is in your pee, by the way. Your pee is actually alkaline. Okay, so you can just pee into your latex. Your latex will remain in solid form. In liquid form. It's disgusting, but okay, it works. All right, so your acid will coagulate latex, as alkali will prevent that latex from coagulating. So you have to know this, right? You have to explain this as well in exam. Okay, so next, what is vulcanization? Vulcanization is to strengthen rubber. Okay, it's to strengthen rubber. As we know, rubber is very soft. Okay, and the most how do I put this? The weakest point of rubber. Okay, why do we not like rubber? Because they don't stand heat. When rubber is under high temperature, they will break down. Okay, they will break down. So to stop this from happening, what do? We vulcanize it. How do we vulcanize it? We add sulfur. All right, we add sulfur. So we add sulfur. So when we add sulfur, right? Can you see this polymer chain, this rubber chain? When you add sulfur, they build these things. We call it the sulfur crosslink. They sort of like build a bridge between these fiber. Now it's very hard for them to break down, very hard for them to slide. Can you see this is just an alloy? I do alloy to strengthen the metal. I vulcanize rubber to do the same thing, to vulcanize, to strengthen the rubber. So now you have all these chains linking all these, your rubber polymer together. Now your rubber polymer becomes, harder, more long lasting. They can stand high temperature, so on. Okay, so this is the difference. You can see the difference here. Vulcanized rubber is everything better than natural because they're hard, they're elastic, they are difficult to oxidize, does not react with acid and alkali. not permeable to liquid and air, okay, and very resistant to heat. So your vulcanized rubber is better than natural rubber, much better. So where do we use this? We can use this in your car tire or your shoe sole. Okay, you know your shoe underneath there's a sole, right? The thing is made from vulcanized rubber. Okay, because they are much better in quality. All right. So that's pretty much it. Okay, that's pretty much it for this chapter. As you can see, it's a straightforward chapter. What you see is what you get. Whatever you study here, whatever you memorize here, it's gonna come out exactly like it in exams. So you should have no problem, studying this chapter. Right? So if that's the case, so let's move on to exercise. Okay, sorry, I forgot to erase this. Let's go to the exercise. So as you can see, the exercise, they are pretty straightforward. They're pretty straightforward. So there are three alloys here, as you can see. So first you have copper and zinc. Okay, when you see copper and zinc, this is for sure brass. Okay, and then you have copper and tin. This is for sure your bronze. All right, so easy. And then your steel, this is, like I said, sometimes coming out, sometimes not coming out. So iron and carbon. So alloys, name alloys P and Q, we did. Bronze and brass. Number two, what is the foreign atom in steel? Okay, so who is the foreign atom? Foreign atom is usually the lower percentage one. As you can see in steel here, the high percentage one, iron is 99%. So carbon is only 1%. So carbon is the foreign metal, right? Because you are the minor one, you're the minority one. So you're the foreign metal, foreign atom. So that would be your carbon. So you can say that tin is also foreign, zinc is also foreign, because copper is the main. Okay, so number three, name the process. This process is called alloying. To make alloy is called alloying. Compare between pure metals and alloy. Wow, so many points I can write here. So you can say alloy, pure metals, they are softer. Alloys are harder. Pure metals are not resistant to corrosion. Alloys are more resistant to corrosion. These many points you can write here. And then number 8, I'm going fast here. If you need me to slow down, you let me know. Okay, so you have your main metal, and then you have foreign again. So this is your brass. Right, you see, brass is made from copper and zinc, right? So who's the main metal? Who is P? Obviously, this is your copper because this takes up the most percentage, right? And then you have your foreign metal. This is the lower percentage one, which is your zinc. Because brass is made from copper and zinc, right? So give the composition of each metal in brass. Okay, we don't need to memorize the percentage, not important. The process, okay, alloying again. Effect of the presence of foreign metal. Okay, why do we need this foreign metal? This is to disrupt the arrangement of this of atoms. Okay, so that atoms are arranged non-uniformly. Okay, so atoms are arranged non-uniformly. Okay, so they are harder to slide. You can add one more. Okay, so they are harder to slide. It makes them harder. Makes them hard to slide. Well, this is a long answer, but you get the point, right? You get the point. So next, number 9. Okay, number 9. So this is object P and your Q. Like I said, object P, this is your musical instrument. So P is your brass. And Q is your bronze. So B, two other uses of the alloy used to manufacture P and Q. So what else do we use brass for? Brass can be used to make keys. Okay, your keys is actually yellow. Your keys are actually yellow. They look silver because they coat a layer of zinc on it. So this is why you look at your old keys, right? You know those keys you have used for 10 years, the zinc will wear off and then you start to see that yellow color underneath. That's the brass. Okay, so Q, bronze is used to make coins. You can say monument. You can say, okay, so many things you can say here. In medals, oh, medal is here already. Okay, so C, why is a bronze block stronger than a copper block? Wow, this is 3 marks. Okay, so why is bronze block stronger? So you can say it has a presence. Okay, presence of foreign atoms in bronze, or the atoms are not arranged uniformly. So layers of atoms are difficult to slide over each other. Okay, it's very hard for you to slide, which makes them, harder. Okay, so you get a point lah, huh? I don't want to write very long answers lah, huh? So this is 3 marks here. So in your opinion, can an alloy which is used to make object P be used to build a ship? Explain your answer. So can you use brass to build a ship? Yeah, you can, but we don't do that because brass is quite soft. Okay, but since they ask it this way, right, of course it's yes lah. Okay, because it is able to withstand corrosion. Okay, better than iron at least. Better than iron. At least this thing, you know, can withstand corrosion. I mean, it's soft lah. It's soft. It's not very. We don't use brass to make ships because it's really soft. Your cars, ships, buildings, they're all made from steel. Why steel? Because steel is really cheap and it's really hard. So that's why your ships, they all use steel to make. So next, glass. Okay, the main ingredient is actually silica. Okay, I don't want to write this. You write this yourself. So okay. So what is silica, by the way? Silica, the real name is called silicon dioxide. Okay, silicon dioxide. It has 1 silicon atoms and 2 oxygen atoms. So that's a silica. So properties of glass, you can write this yourself. They are chemically inert. They can withstand high temperature. They are very brittle. Okay, so many things you can write here. So we're gonna skip ahead. We're gonna skip ahead. I don't want to spend time on glass and ceramic because there's very low chance they're coming up. They're coming out. So next, let's go to 13. What is this process? This is your polymerization. Okay, that means you take all these monomers. You see these polymers, you just join them together. So you get a polymer. Right? So again, we skip. This is not important. So let's go to let's go to 15. Okay, let's go to 15. So this is your rubber. Okay, this is your rubber. And so what is number 1? Number 1 is your protein membrane. Okay, your protein membrane. They're lacking some charges here. It should be negative charge at the outside here. Right. So what is inside this thing? This is called your protein polymer. Okay, your protein polymer, all the the things you need is inside. So rubber polymer rubber particles do not collide against each other. Explain this statement. Because you have negative charges on protein membrane. Okay, negative charges. So what will do? They will repel each other. Okay, negative, negative, they repel. So C, why does latex coagulate after being left aside for a few days? Okay, as I said, you can say bacteria in air produce acid. Okay, so what does acid do? I can say, you can say the acid neutralize negative charges on protein membrane. Okay, so they will neutralize everything on the membrane, so they will now crash together. So now they coagulate lah. Okay, next, natural rubber and vulcanized rubber. So as we know, vulcanized rubber is everything better. Okay, they are more elastic. They are stronger. They are high. They have higher resistance. Okay, so vulcanized rubber can stand heat. Right, nowadays, we mostly use vulcanized rubber. You know your wiper? You know your car wiper? Your car wiper is also made from vulcanized rubber. That's why if you park your car under the sun, your wiper will be okay because you know they are made to stand heat. So they will be fine. So everything is less here lah. Natural rubber, everything is less here. So one use of vulcanized rubber, we can use it as our shoe sole. Okay, shoe sole. You can say tire, you can say even glove I accept because some glove they are vulcanized. It's some lah, the expensive ones like the more pricey ones. So 16, latex was chemical Q, they coagulate. So what is this chemical Q? This is definitely an acid, isn't it? Because latex is positive, acid is positive, it will neutralize the charge, so they will clump, they become coagulated latex. So what should be chemical Q? Any weak acid will do. You can say formic acid. Okay, formic acid. Don't use strong acid. I don't use like what? Hydrochloric acid. No, that's an overkill. There's no need. So one characteristic of chemical Q, what is acid like? You can say pH less than 7. The acid is less than 7. This is form 2. What will happen to the latex if chemical Q is replaced with ammonia? Chemical Q is replaced with ammonia. So this is alkali actually. So you can say latex remain in liquid form. Right? Latex remain in liquid form because the negative charge they remain. Okay, so number C, when you add sulfur, this process is called vulcanization. So rubber V is your vulcanized rubber. Vulcanized rubber, that means they are harder. So, as I said just now, your tire and your shoe sole. So between the natural rubber and rubber V, which is more suitable to be used in making those products? Of course, you would use rubber V. What's a rubber V again? Oh yeah, that's a vulcanized. Okay, so explain, justify, answer why V. Because they are able to withstand high temperature. Or you can say they are more elastic, they are stronger, they are harder, everything. So your tire and your shoe sole, they're made from rubber, vulcanized rubber. So your vulcanized rubber should look like this. Okay, and it's two S's here. I mean, I'm drawing it simple, so two S here. So your vulcanized rubber should look like this. Okay, two S here. And the S is like a bond. Okay, so two S's here. So what is substance X? So how do we add this sulfur? So X is sulfur. X is sulfur. So the sulfur will join the links together. So give the function of the substance in A. So it will form your sulfur crosslink. It forms sulfur crosslink. You can say prevent rubber from deforming, or you can say making it harder. You get it stronger or harder. So you just add sulfur. Right, so state the type of rubber that's suitable for making tires. Okay, again, that's your vulcanized rubber. So two properties of requirement for tire. They must able to withstand heat. What else? They must be hard. Okay, because you're bouncing it on the road. So they need to be hard. Right, so why is tire so hard, by the way? Your tire, okay, just to let you see here, okay, so your tire, right? If you look inside your tire, there are actually metal fibers in it. So that's why your tire is very hard. Your tire lasts for a very long time. Because inside they have these steel belts on it, so that they will stand, they can last for a very long time. You change your tire when the tread is no more. Not because the rubber got worse, because your rubber wouldn't get worse faster than the tread wears off. So that's why you change a new tire. Right, so again, number 18, this is your experiment. So the effect of vulcanization. So you can see this is vulcanized, this is natural, this is the original length. And when you attach weight to it, you see, vulcanized, they will only go to 8. Your natural will go to 9. What does it mean? That means vulcanized is stronger and harder. If vulcanized is stronger and harder. That's why they don't deform much, they don't move much. So when the weight is hung, state the difference in length. So from 7 to 8 is 1 cm. 7 to 8. And then 7 to 9, this is 2 cm. Simple, huh? So what can you infer from the answer? So what can you explain from here? You can say vulcanized rubber is stronger. Or you can say harder, same thing. So C, after the weight is removed, the length of natural rubber tree is 8, while the vulcanized rubber is 7. So you see, this thing doesn't return back to its shape. It stays at 8. It is permanently deformed. You know, when you play rubber band, right? If you pull it too long, before it snaps, when you bounce it back, the thing just kind of look deformed really. It's not as tight as when it's new. So this is what we call deformation. Natural rubber, they are very soft, they're very easy to deform. Whereas vulcanized rubber, they are much tougher. So that's why. So which rubber is more elastic? Of course, it's vulcanized. Okay, because why? They can return to original shape. From 7 to 8, sorry, from 7 to 8, then back to 7. So it's flexible, it's elastic. Whereas your natural, they go from 7 to 9. And ever since they never went back, they will go back to 8. So because it's permanently deformed. What is the meaning of elasticity? Wow. how do I put this? The ability is an ability. Flexibility is an ability. Elasticity is an ability. The ability of an object to return. Okay, to return to its original shape. Okay, when load is removed. Wow, that's a long answer. Okay, that means you take off the load, they can bounce back to the original shape. That's the meaning of elastic. Right? So if you put your force on, let's say, plasticine, you know plasticine, right? Or clay, when you put your force in it, it is forever deformed. That is what we call plastic. Plastic. Okay, so elastic and plastic, they are different, very different property. You say that rubber is elastic, but you say that clay is plastic. So plastic is not actually, the plastic you use. Plastic is actually a characteristic. Okay, so the more you know. So the hypothesis here, you can say, you can write back the same thing. Vulcanized rubber is stronger than natural rubber. You can write back the same thing. Because you cannot say more here. The more vulcanized, the more, you just write the prediction. If in the case of you cannot write uh more and more, less or more, okay, our usual uh formula, then you just write a prediction. Okay, just write a prediction. So what is the MV here? MV is the type of rubber. Responding is the length of rubber. Change in length. Or change in length. So what's your constant variable? What's your CV? You can say the mass of load, they have to be the same kg. The measurement of the rubber, both needs to be the same measurement, same thickness, same length. Right? So F, vulcanized rubber, is used to make car tire. Why is it suitable? Because it can withstand heat. Same thing again as just now. So I don't know whether you notice this. The question has been very repetitive. Okay, because you keep seeing the same question again and again. So wow, that's all. Okay, that's all. Right, since we've done everything, right? Okay, you know what? I'll give you the answer for the rubber one lah. Sorry, the glass one. Okay, since it's empty anyway. Oh, by the way, this answer is already posted in Google Classroom. Please check it there. So the major component of glass is silica. Okay, this is actually chemistry. Where can silica be found? In your sand. Name the element found in silica. That will be your silicon and oxygen. Properties of glass, as I said, they are brittle. They are chemically stable or inert. That means they won't react with anything. Glass is very easy to wash because your food residue doesn't stick to it. Right? They are transparent. Okay, oh, how can we forget this point? So main component in glass and ceramic, that would be your silicon dioxide. Okay, that's the main. So your apparatus made of glass. What type of glass is used? Okay, so right. You see, all these apparatus, they are very stable and expensive. So we use borosilicate glass. Borosilicate is the expensive type. Okay, fused is the middle. If you use pure sand and make pure glass, that's the middle strength glass. Not too good, not too bad. The weak ones, we call it fused. That's the cheapest glass. You drop to the floor, confirm the thing will shatter. Borosilicate is the high class one because it's very stable and it's very stable basically. Okay, so B, how is the type of glass you selected in the manufacture of the above product? Why choose borosilicate? Because they are chemically inert or chemically very stable. So another type of glass, what else can you use? You can use your fused glass. This is the second the middle glass. Okay, the middle glass. Not too expensive, not too cheap. The cheapest one, oh sorry, I think I messed up the name. The cheapest one was called soda lime. Okay, soda lime. This is the cheapest you can get. If you buy those 5 or 6 ringgit cups, glass, those glass from Mr. DIY or Daiso or whatever, chances are they are soda lime. Very cheap. They will just chip easily. You drop them somewhere, they will just crack into half, really soft. So fused glass, explain your answer, because they're also chemically inert. Remember the same thing. Also chemically inert. So D is the glass used to make the product above suitable to make drinking water containers to be used in restaurant. Well, yeah. Okay, yes. You can use glass to make to put drinking water. Why? Because they are easy to clean. Because they're chemically inert. If you want to say no, because they are brittle, easy to break, yeah, sure. This has two sides. Two sides of answer. You choose whatever side you wanna write, lor. Up to you. So next, ceramic main component in clay, that would be your aluminium silicate. Almost the same thing. The point is, silicon dioxide, your sand is transparent. Aluminium silicate is not transparent. They are opaque. That's why your bowl you cannot see through. Okay, ceramic cannot see through. So an advantage and disadvantage of ceramic. Advantage is they are very stable, chemically inert. Disadvantage is they are brittle. Again, the same thing as your glass. Ceramic cannot be recycled because they cannot be melted and reshaped. Glass can be melted and reshaped into anything you want, right? Ceramic you can't. That's why ceramic, when you break it, you have to throw it away. So two other uses for ceramic, besides making a bowl, you can use ceramic to make insulator for spark plug. For your car spark plug, the side is made from ceramic. What else you can make here, usually they don't ask this. Oh no, it's not mentioned here even. Okay, insulator basically I think of is insulator. You can say make vase. Okay, although vase is porcelain but whatever, you get the point, it's the same thing. Okay, so next, glass, we use it to make apparatus. Okay, we use it to make glassware. The ceramic, we use it to make bricks and cement. Oh, that's the answer. We use it to make insulators. As I said just now, use it to make insulators. So, student was dazzled by the sunlight while doing her homework. She wants to change the window glass. Okay, now something to do with light. Okay, see, fused glass, soda lime, and borosilicate, they are something to do with container. If you want to reflect light, you don't use these three, you use lead glass. This has high refractive index, that means they bend light very well. So they sort of act like diamond. So you use this in your chandelier, that's why they sparkle. Right? Wow, we are very fast today, we kind of finished this thing like real quick. Okay, so I think I'm gonna stop here This polymer one, I don't really care because it's not really coming out. So if you really want to answer, the answer is already posted in Google Classroom. You know where is it, right? I put it under classwork, the second column. You search there, you should find it. Okay, so thanks for coming. I will see you again next week Okay, you will receive your new notes by next week. So we'll do revision again. Right, so thanks for coming. I will see you next week. Take care. Bye-bye.